Hi students, today I am going to discuss the cryptography transposition techniques. So in previous class I explained the concept of the substitution techniques. So either the substitution technique and the transposition techniques, these two are comes under the classical techniques. So because the cryptography is divided into the two parts, so one is the conventional cryptography and second one is the public key cryptography. The conventional cryptography again divided into the two parts. The one is the classical techniques and second one is the modern techniques. So what is the use of the classical techniques? The classical techniques are the techniques which are encrypted the alphabetical data, that is the textual data is encrypted by the classical techniques, and the modern techniques are nothing but the modern techniques are the techniques which are encrypted the binary data. So here the two inputs data, two types of input data is taken in the computers. One is the alphabetical data and second one is the binary data. So the alphabetical data is encrypted by the classical techniques and the binary data is encrypted by the modern techniques. And coming to the classical techniques, again the classical techniques are divided into the two parts. One is a substitution technique and the second one is a transposition technique. So what the substitution technique is nothing but each element in the plain text is mapping to the other element. Each element in the plain text is nothing but the plain text is in the form of the textual data. The element is nothing but one alphabet in that particular text is nothing but the element. Suppose we have to take the input data is like MEET, meet. Now in this, what is the element of the that is a text is nothing but the M. M is a one element, E is an another element, E is an another element and T is an another element. So each element in the plain text is mapping to the other element. So M is mapping to the other element, E is also mapping to the other element, E is mapping to the other element and T is also mapping to the other element. This is the substitution technique. And coming to the transposition technique, in the transposition technique, each element in the plain text are rearranged. So each element in the plain text are rearranged. That means here we don't mapping the element to the another element, but in the transposition, whatever the position of the element is, so that we have to change the position. For example, here M position is 2 and E position is 3, E position is 3 and T position is 4. Suppose I have to write in the transposition, just I have to take the E and T and M and again E. So the meet should be converted like this. That means the element cannot be changed in this plain text, but the element position may be the change. That's why here the E position either the 2 or 3 or T position is the 4 and M position is the 1, and if you write the 1 position of the 2 of E and then the position of E is 3. So 2, 4, 3, 1. So that means we have to write some permutation related to the transposition. So the transposition is a technique which is the each element in the plain text are rearranged. That is, we have to make it some permutation order. So we have to prepare the plain text into the permutation order. Now we know some of the keywords of the cryptography is nothing but the original message is called the plain text message. So the secret message or the converted message is called the ciphertext message, and the encryption is an algorithm which is convert the plain text into the ciphertext, and decryption is an algorithm which is convert the ciphertext into the plain text with the help of the a key. A key is a value which is independent on the plain text message that I have to be explained in the starting video, that is the introduction of the cryptography. Now coming to this particular transposition technique, so there are different types of transposition technique is there. So that is the row wise transposition techniques and the column wise transposition technique. The row wise transposition technique is nothing but the rail fence technique. So here basically there are three important techniques are there, the majorly. So the first one is the rail fence transposition technique, and the second one is the column wise transposition technique, that is the columnar transposition, and the third one is the Verman cipher. So here the rail fence technique is nothing but the technique, it is the row wise. So row wise transposition. So the second one is the column wise transposition, and third one is the Verman cipher. So the Verman cipher is one of the technique. So coming to the first one is the rail fence technique. The rail fence technique is also called as the a row wise technique. What the row wise technique, this particular algorithm is nothing but now we make it arrange the given plain text into one particular order. What that order is, this rail fence is defines one of the technique, like you can observe. This is nothing but the example of this. Suppose we have to prepare the message into the diagonal form. So here you make it observe. This is an input. All the input message can be arranged into this order. That means this is a diagonal order. So the first we can return the message. So into the zigzag order is nothing but the diagonal order. So that's why whatever the message we have to taken, for example, so here include help is awesome. So this is the one of the message, that is one of the input. So how we can write that particular include help is awesome message is nothing but, so now you can observe this is the diagonal form which I represented. So include, so I is the in this position, N is in this position, again C is in this position, L is in this position, U is another. That means we have to prepare the message into the diagonal form. So all the message once we have to prepare. So what this particular rail fence technique is nothing but we have to prepare the message like this diagonal form, and we can read this message in the sequence order. So how we can prepare the ciphertext message based on this? Now you can observe here the two row wise data is taken. The first row is ICUEEPSWSM, and the second row is NLDHLIAEOW. Now I have to write the first row is the first one, and second row is the second one. I have to combine these two rows, and finally I can prepare the ciphertext message. So this is the simple technique of the transposition technique. The element cannot be changed, the element cannot be mapped to the other element. So whatever the element is taken in the plain text, so that element should be write in a different order format. So this is what we have to be observed in this particular example. Now this is the rail fence technique. So what we observed in this rail fence technique is nothing but whatever the message, whatever the input is taken, that input can be prepared in the diagonal form and prepared of the ciphertext message into the sequence order. Sequence order in the sense row wise, first row data is taken and second row is data is taken. So this is the first technique. And second technique in this column wise transposition technique, the column or transposition techniques are again the considered in the a basic technique, and second one is the more than the one time encrypted technique. So more than the one time technique is nothing but a column technique with multiple rounds. So that is called a column technique with multiple rounds. So what the column transposition basic technique is nothing but, so whatever the message is taken, that is an input message, that message can be prepared in the column wise order, that is a matrix order. So matrix order in the sense the key size is taken, so one particular, so we make it arrange that particular plain text into the key order. Suppose for example the key is nothing but the A4321 for example. So the message is nothing but meet me. Suppose I have to prepare MEET and again continue ME. So the remaining two letters, what about if it is contains the empty two letters? The empty two letters can be filled with either sequence order, that is an AB or the XY, either AB or XY or YZ like that. That means the remaining two positions can be filled with a sequence order. So this is the column transposition is taken. So it is a basic technique. So in a rectangle predefined size, that is already predefined size should be taken. So that is the row wise and the column wise data is prepared, and based on that particular column order we have to convert the message into the ciphertext. For example, here the plain text is taken, that is the include help is awesome. So here whatever the message is taken, now you can observe this is the column. So what the 4 columns I have to be defined, the column 1, column 2, column 3, column 4. Now I can write the message in a sequence order. So include INCLUDE, include help is awesome. That means the total message can be prepared into the a one by one order, that is the column wise. So the column wise 4 columns can be filled the exact data. So if any remaining field is defined here, the remaining empty field can be covered with the sequence letters, either the XY or the XYZ or the ABC, like that. So now this message can be prepared into the column wise. So that means how we can prepare the ciphertext here? What is the first column? Suppose the key size should be taken 4132, for example. 4132 in the sense, what is the fourth column data? That is an LHIEEE. LHIEEE. LHIEE. This is the first column message. Because of why I have to write this first one 4132. This is the key size. So now I make it arrange the given plain text into this column order. Now I have to take one more permutation. Actually this permutation is nothing but, what is this permutation? 1, 2 and 3, 4. This is the actual. Now I can prepare the permutation 4132. The first column data is LHIEE. Write that first one. Here you can observe. So what the exact output of this particular ciphertext. Now a ciphertext can be prepared in this. So what is the ciphertext in the first column? First column order LHIEE, and the second one 41. Was first column is IUESS, and next one third column data CEPWM, and the last one is the second one. So what the second one is nothing but NDLAO. Now you have to observe all the message should be taken in this order 4132. So in this particular basic transposition is nothing but a pre-order column wise data is prepared because of whatever the permutation we have to be taken. So all the data should be converted into this particular permutation order. So that is 41232. So the 4132 is the permutation order. Now I have to convert this particular column wise data into this column order. Now I get the ciphertext message. So this is the very basic transposition technique. And next one is a column transposition technique with multiple records. Here you may be observed multiple rounds are taken. Multiple round. What the multiple rounds is nothing but whatever we get the first output. Already we can observe here, we get some of the output is after completion of the first round. This is the basic round. So once I have to be completed the basic round, so what type of data it is? You can observe the data is the LHEE IUESSCEP WMNDLAO. So this is whatever the key order message is taken. Now the same order we have to be taken in the column wise. In the include help is awesome, the same example. So that is the first round. In the column technique with multiple rounds are taken. So whatever the exact message we have to be considered, so we can encrypt it more than the one round. Now you can observe. So this is the message we have to be prepared the same order. Include help is awesome. Now the total message is taken in this order. This total message now I can prepare in the second round. Now after completion of the first round, I have to take in this particular message. Now that message is converted into the another one. So with the help of again I can write this particular message, that is LHIEE. Now you can observe LHIEE. Like that, in the initially whatever the message we can write and prepare this one ciphertext, the same ciphertext will be taken the input of the second round, and I make it arrange the data into this particular order, and finally I have to take the 4132 message. So based on the 4132 message, I have to prepare 4132 message 32. This is the key order. So first one is the triple E NO. So the same message you have to be considered triple E N. So here triple E N L, triple E N O, and the second 4 one is LESPD, LESP. So here the one column I should be omitted because of, so except that particular round one, I have to taken the each and every column wise message. The column wise is taken the 4132 here. The similarly, this is the first one, this is the second one, and this is the third one, and this is the final one. Now I have to prepare the message, and finally I get this particular. So this is the transposition technique with multiple rounds are considered. This can be round, you will be continue. It provides more secure. So why we can use this particular transposition with the multiple rounds are nothing but it provide more secured compared to this particular thing. Now I have to consider the third technique is nothing but the Varnam cipher. What exactly the Varnam cipher is nothing but the Varnam cipher is a technique, a specific one-time pad. One-time pad is nothing but whatever the message is we have to be considered. The one more message we can add the original message. Now you can observe, for example in this particular example, include help is one of the message. So that message should be taken, that message padding one-time pad. One-time pad is nothing but I have to take this particular data. So in this I have to relate the alphabet number. What is an alphabet number of the I? That is an 8. Whatever the alphabet number of the N, that is 13. Why? Because I have to start it from A is 0 and B is 1 and C is 2 like this. So I just taken the I message is the I letter is the 8, N message is the 13 and C message is the 2. Why? Because C is the 2. So I have to start it from the 0 and L message is the 11, U message is 20, D message is 3 and so on. So now whatever the include help is taken, all the include help is converted into the number which is related to the alphabet. Now I have to take one more message, that is ATQ XR Z WOBYV. This is one time pad I have to be used. So just I can add this particular message into include help. Now so what the ATQXRZ, I have to take the number. A becomes to the 0, T becomes to the 19, Q becomes to the 16 and X becomes to the 23, R becomes to the 17 and so on, V becomes to the 21. Now I can add these two. So 8 plus 0, that is 8, 13 plus 19, 32. So next 2 plus 16, 18. Here 32, how I can convert the 32? 32 mod 26. When I take the mod letter, 32 mod 26 becomes to the 6. Now I have to take each and every letter can be added with the number, that is here I becomes to the 8, A becomes to the O. So I can add 8 plus 0, that is 8, 13 plus 19, that is 32, 32 mod 26, 6, the result value is 6. Here you can observe that the result value is 6 and the next one 2 plus 16, 18, 18 mod 18, 18 mod 26, that is 18. Next one 11 plus 23, 11 plus 23 is 34, 34 mod 26, that is 8. So I have to calculate it like this and finally I can prepare the message like this. This is the Varnam cipher. So IGSIELCA, whatever the value. So here you can observe whatever the resulted value I have to be taken, the related alphabet I can write and finally the cipher text can be derived. This is the Varnam cipher. So these three are the transposition technique. We know that here no element can be mapping in the transposition. Whatever the element is considered, so we just taken the element in the replace order. That means rearranged. So the order may be the change. The permutation we have to be taken, but the element cannot be changed. So these are the techniques. The first one is the in this particular column transposition. The first one is the rail fence technique. Rail fence technique is nothing but the row wise technique, and coming to the column transposition techniques are taken the two, the basic transposition technique, and second one is the column transposition technique with multiple rounds, and third one is nothing but this particular Varnam cipher. What the Varnam cipher is nothing but, so one time padding. So already we take the plain text and we had some of the message to the plain text and we take the number of the alphabet related. So we can add these two and finally we can derive this. So this is the total technique of the transposition technique. Thank you.